It's recording now. All right, so let's go ahead and share. All right, yeah. So like I said, in the recording, I missed this part, but there's the code that's on Squeeze, so you can play with this. All right, and now we're doing read CSV, okay? And basically, we are going to read from, I already provided that in the zip file. So it's a white wine from Portugal data set, and we're just going to play with it, load it into a tensor. That's really our goal so far. And then later on, obviously, we're going to start to do some machine learning. So the path should be in data, and then there should be a file in there called wine quality white dot CSV. All right, so as I was saying, it's a comma separated file like Excel, rows and columns basically, but they're only separated by commas. So we can actually take a look at that file because it's available from our Jupyter notebooks here. So if I click on data and I click on data, there's the file, wine quality CSV. So if I click on that, that's what it looks like. So usually, oh, there we go. So usually, every row is a sample, basically. Notice that the samples are separated here, actually by semicolon, right? Do you notice that? There's a semicolon separating everything. So bear that in mind. And then we've got the first row is actually the column headers. So it's fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, free sulfur dioxide, total sulfur dioxide density, pH balance, sulfates, alcohol, and quality. All right, so the first are the features. The last one is the predicted value, the Y. Now, in this case, if you notice, the values are numbers like 6, 5, but if I remember correctly, when I read this data set, it's a qualitative thing, okay? So it's saying a ranking that was given to them. This is a wine, a 6 wine, or a 7 wine, apparently, and that costs more money or something, right? So that's kind of the idea. So basically, people would look at those variables and input that into their model, and boom, it would tell them what quality wine it was going to be, and then you can determine how much you should charge for it, and so on. Got it? So that's the value of it. Anyway, so this is the data that we want to read. Notice that the important thing is that we need to separate here by semicolon, basically. We know that there's a few features, and then the last one is that's also important, is the actual thing that we want to predict. So we got the X and the Y vectors, okay? So we can go back. Let's leave that there. And let's go back to the file. Any questions about the data? Pretty straightforward, right? That's what the great thing about regression data, it's always very straightforward to understand. All right, so now that we have the path, we can go ahead and read it in. Again, there's tons of ways of reading. Pretty much every framework has a technique. In our case, let's just try NumPy for now. So I'm going to do wine Q underscore NumPy or NumPy or NP, however you want to do it. And now we're going to call NumPy, right? We had already imported that. And we're going to say load txt. All right. And then we're going to specify in here wine path is where the file is located. Okay, now the delimiter, this gives us the option of specifying the delimiter, which in this case is not the standard comma that we would expect. It is actually a semicolon. So let's go ahead and mark that in. Semicolon like that. Skip rows. Do we want to skip? Now, to load into a NumPy array or a torch tensor, you definitely need to skip the column names. However, is it useful to have the column names? Yes. What tool might allow you to bring in column names and data at the same time? Pandas, right? And that's why Pandas is such a great, really nice tool. And we're going to play with that later on. I'll show you guys how to, like, you know, do those things. But for now, skip rows. We're losing some information with this approach, but so skip rows. So I think it starts at 1 here, so it's 1. So that just means skip the first row. And then we want to specify that the data type for this numpy array is going to be float. So d type equal np dot float 32. This comma right. Yeah. Do you guys see that? So this is now, hopefully, the data as a numpy array. So let's hit enter. No error, so that's good. So that means this should be now a tensor in numpy. So let's go ahead and print it. We can, let's see. So we'll know the shape right now. Let's actually do that. So line q underscore numpy dot shape. Does this make sense? This is kind of like the very first thing you want to do. Okay, what does this tell you? You see how this is very similar to the X and the Y exercises that we did? Okay, related to that, and tell me what this is, please. There are how what? 4,890 examples. Okay, very good. 12 features. No. There's 12 columns, right? And the last one is the quality. So that's the Y. And the X is the features are 11. You see that? So basically your X matrix is 4898 by 11. And your Y vector is 4898 by 1. The last one. You see that? Okay, great. So we have it. We printed it. Now, what do we want to do? We want to convert this into, since, you know, at the end of the day, we want torch, right? So let's convert our numpy array to torch. So let's go ahead and do that. It becomes a torch tensor, and then we can start further processing. Now, this slicing you should be able to do by now, okay? So I'll let you guys tell me what it is. But let's do line q equal and convert it to a tensor. So that's just torch dot from numpy, right? Remember that function? It's like the 3rd or 4th time we use it. All right, so from numpy. Oops, sorry. Okay, and it's gonna be line q numpy. Just like that. Run it. Okay, so it is now a torch tensor. Very straightforward, really. Not really that complicated. And now comes how we tie the numpy problems to the word problems, right? And in our way towards machine learning models. So whenever you do this, you want get X and Y. That's what I want, right? Because usually a lot of machine learning models take this like that. So mark down here, run it. Okay. So this is like an exam type question. I want the X, and the notation is usually uppercase X, even here, and lowercase y, right? So, all right, slice it. What the data is in line Q, right? So that much we know. Line Q. Line Q. Okay. Now comes the slicing. Yes.
last one's quality is what it is. That's like it already knows.
It's what we want to predict.
So won't we need to slice 11 to get everything up to 11?
Say that again.
We need to slice to 11 to get everything up to 11, right?
Okay. Now remember, off by one errors, right? So keep that in mind.
Oh, okay.
So, you need to tell me though, like the slicing. This is what I'm asking. You're right. So square brackets here.
Yeah.
Right, Lenny?
Yeah. And then
Square brackets here. Okay. Now what goes in here?
you need a colon.
Cool.
Uh, 10 can go up by 1.
I don't know. You tell me. And then what else? What about for this one? You want me to do -1 here? Just -1? Colon? And then what? Switch them? You mean -1 first? No? Like this? Okay. This one you should be able to do, okay? Even if you can't do it now, you really need to be able to do it by tomorrow. You know, this you need to do. The other ones were hard, but this you need to be able to do. It needs to start to click. So, 12 where? 12 like that. Okay. Okay, well, let's print the shapes, right? That's kind of how you print x dot shape. For which one? You mean that? Okay, so, okay. You just totally changed the thing to something else.
So she's good with that, but I would like to add that stop is always -1. So you would want 11 instead of 10.
11. So he says 11. Do you want to stay with that colon or retract with your statement?
I like the colon.
You'll stay with the colon. Good. That's a good choice, right? So, yeah, that's right. You were right. So, this just means all the rows, right? Do we want all the rows? Yeah, we want all the samples, right? The features that this contains, all the features plus the last column is the predicted value. We don't want the predicted value in X, right? That's going to be in Y. So then we slice it from the beginning to say 11. And then we do, we do shape. And 4898, that's good. We had 4898. And now we've got 11 before we had 12. That sounds about right because it's the last one that we don't have. You see, it's like we popped out one column. That's why it's called slicing, right? It's like a cake. You sliced out that part. That's great. So it's kind of correct, right? It's correct. All right. So the next one then, what do we do here? Yeah, please.
That one, we just want to get the last column, right?
Yes.
So couldn't we do then colon and then 11 with no colon, just get the 11th one? Yeah.
Okay. Right? Because exactly, this gave you the range of all of them. This only gives you the given column. So it's indexing.
So the colon 11 would stop before 11 and only get through 10, right? But if we just put 11.
That's right. That's right. So exactly. It doesn't include the last one. You're right. All right. So I'm going to hit this. Oh, I forgot the shape. Print. Y dot shape. 498. And it gives you that. There should be 498 in there. Comma 1. Why is comma 1 not there? Does comma 1 need to be in there? Sometimes it doesn't. Now, let's say that you do want it in there. What do?
Then I would.
What did you say?
Colon after the 11.
On squeezing, on
Oh, yeah,
squeezing,
you can
on squeeze, right? So we just learned on squeeze. See, that's a perfect example of why on squeeze might be a thing. So torch on squeeze, right? I'm going to copy this one over here. And because you're thinking, I want 4898 by 1, right? That's kind of what you want. So then this will be, let's call it y new, just, yeah, y new. And then here it takes y, right? And then what? 1. Okay. So now we want to print y new dot shape. And that's what you wanted. And that may be something you have to do sometimes. Like the operation may require you not to have it in this format, but explicitly have it as a column vector. That can happen. Got it? Make sense? All right, good. Now, if you getting that indexing was tough, and sometimes it can be tough. So another approach that you can take is an interesting one, actually, which is to do -1. The -1, if you start from here, when you use -1, you're starting from the other end. Does that make sense? And so that way you don't even have to think, like, and so still the dimension, still 488. So the -1 is a good thing, especially like if you're processing multiple images of different sizes or not images, sorry, data sets, etc. A more general approach is just, and you know the last column is always the y, then you can just use -1. And then give you whatever shapes it gets out of it. Any questions? Yeah, please. You can for this particular scenario where the last column contains the y vector. Yes, it's the y vector. What you want to predict. Got it? All right, perfect. All right. Yeah, so that's that idea. And that's usually what we're gonna be doing. I think. So we've tried on squeezing, we've done normalization already. So our data is in X and Y. At this point, our data is in X and Y, so it's really ready for the next step, right? Feeding it into a model. All right, so that's one example of reading in images, and then one example of reading in CSV files, okay? So the next thing we're gonna do now, we're gonna switch back a little bit to the images of the 3 cats that I had, and we're just gonna play with them for a little while, and that's kind of like, reading data. After that, we're just gonna start to get into our very first real serious PyTorch problem, okay? So let's just, let me actually, I should have been like creating smaller videos. I forgot about that. But anyway, I'll stop it and start it again here.